So is your data normal, or does your data follow normal distribution? Because if you intend to use parametric statistics to analyze your data has to fulfill one of the criterion, which is it has to follow normal distribution. So there are several ways you can test to see whether your data is normal. One is by carrying out a normality test. For example, Shapiro-Wilks test that will show whether your data fits the normal distribution. Pass. So in pass, you can carry out the test under the menu heading univariate. There's a normality test here. So these are counts by the AGA chromocult media. So you can see that in Shapiro-Wilks test, the probability that it is normal is less than 0.05. That means the data that you have here does not fit into normal distribution. So these are bacterial counts where you can log transform. So I've prepared this column here for log transformation under this menu. Then we'll do the normality test again, and you can see that in Shapiro-Wilks test, the P is no longer less than 0.05. It is no longer significant. That means the distribution, the data that you have follows the normal distribution. Okay. So you can see how log transformation has changed your data set from one that does not follow normal distribution to one that follows normal distribution. So log transform data can be used in parametric statistics, for example your t-test, your ANOVA. You can also view whether your data follows or fits well the normal distribution using a probability plot, a QQ plot, or quartile plot. So in a probability plot, QQ plot, quartile plot, on one axis your observed data are sorted from smallest to largest, and on the other axis is the expected data if your data follows normal distribution. So here you can see the QQ plot before log transformation and after log transformation. So after log transformation, your data fits the normal distribution well. So in pass, you select your column that you want and then go to plot, normal probability plot, and that's it. You have this plot here. You can even see the correlation coefficient. So if you are looking at the transform data, you can carry out the same test, normal probability plot, and you can see that the correlation coefficient has increased to 0.97. You can also draw a histogram. However, this solution is not suitable if you have a very small sample size. Biovolume data measured from bacteria. So if your sample size is small, and if you plot a histogram under plot histogram, you will not be able to see any pattern. However, if your sample size is larger, then you will be able to see clearer. Okay, you can see that this distribution is skewed. Sometimes results may be misleading because of outliers in your sample. So outliers can be categorized as mild outlier outside the plus minus 1.5 standard deviation, extreme outlier outside the plus minus 3 times standard deviation. Some papers will define outliers as outside the plus minus 2 times SD. So in past, it's very convenient to find outliers by using a box plot. So a box plot is a standardized way to show the sample median, this line here, your first and your third quartile. You have a white circle, an empty circle as a null outlier, and an asterisk as a extreme outlier. So the top and bottom whiskers here are the largest and smallest data point less than the null outlier. So this is the last point, less than the null outlier. So how do you go about drawing this and paste it? Select the column and plot bar chart / box plot. Here you can select bar chart, box plot, and other plots. So box plot. So here these are the minimum and the maximum whiskers. However, if you take outlier, then the null outlier and the extreme outlier is shown. Okay, so this is how you plot a box plot and to observe for outliers.